some topics that are related to exam, and then again, it's mostly going to be exam focused topic. Okay. We are going to start with simple harmonic motion. Simple harmonic motion. And each of the topic, I'm going to solve most of the exam possible question of them. That is, first of all, we are starting with simple harmonic motion. Okay. Let's know what simple harmonic motion is before we solve a question on simple harmonic motion. All right. Let's know what simple harmonic motion is before we solve any question on simple harmonic motion. All right. Okay.
Okay, we have one viewer, but for now, yeah, so listed reach it out. We have to bring it from.
Okay. But I think send the link to me.
Yeah, I've just copied the link. Since your phone is Samsung, okay. I think it has quick share.
Okay.
I'll share the link now. Quick share. There's one view and one right. Let me share it faster. Okay.
Yes, it's okay.
Review.
Oh, okay. I'll share.
Yeah, so that's the career.
Okay. No. All right. Good afternoon. Now, in our class here, I'm starting with simple harmonic motion. But before then, I have to apologize to you guys. I'm very, very sorry for inconveniency. The class is supposed to start by 12, but we have to start by 1:54 because of some certain condition. Okay. Now let's start with this. Now in our class, I will introduce a topic and solve an exam possible question in that topic. And we are starting with simple harmonic motion. Okay. Now let's first of all understand what simple harmonic motion is. And I'll give us some notes, like some key points you have to know on simple harmonic motion. Okay. Let's write. Simple harmonic motion can be defined as a periodic motion. Simple harmonic motion can be defined as a periodic motion. All right. Or a repeated motion. Okay. When they say periodic, is the sentence as repeated. All right. Or a repeated motion. Which acceleration is directly proportional to displacement at a fixed point. Okay. Which acceleration is directly proportional to displacement at a fixed point. Okay. Now, in terms of simple harmonic motion, please like and share in your departmental group. Like and share in your departmental group. Okay. That means the acceleration here is directly proportional to what? To the displacement, and this displacement must be at a fixed point. Okay. So that is the first point in simple harmonic motion definition. So now let's look into the next one here. Please write formulas relating to simple harmonic motion. formulas relating to simple harmonic motion. Formulas relating to simple harmonic motion. When you see SHM, is the same as simple harmonic motion. So let's take some of the formulas relating to simple harmonic motion, apply them in some questions, okay? Okay. It says to be period. Okay, let's know what period is, please, right? Period can be defined as the time taken to cover one oscillation. The time taken to cover one oscillation. It can be denoted by capital letter T. It can be denoted by capital letter T. Mathematically, period T can be expressed as 1 over F. Mathematically, period T can be expressed as 1 over T. The next here is said to be frequency. The next here is frequency. Now, we denote frequency by using F. Mathematically, frequency can be defined as, please take note of that, as F equal to 1 over T. Frequency can be defined as 1 over T. The next here is said to be angular frequency. Angular frequency. And we use W to represent angular frequency. Now, mathematically, angular frequency W can be defined as 2 pi F. Mathematically, can be defined as W equal to 2 pi F. Now, listen. Sometimes this omega can change depending on what you are relating omega with. If you are relating omega with frequency, you call this omega here angular frequency. But if you are relating omega with velocity, like V is equal to omega R, like this, we call this angular velocity. If I'm relating this omega with frequency, I'll call this omega angular frequency. If I'm relating this omega with velocity, I'll call this omega angular velocity. Please take note of this here, okay? Now, we can also write the formula for angular frequency in terms of spring constant or stiffness. And that is going to be omega in terms of spring constant can be square root of K over what? M. Please take note. Okay, now these are the formulas we have to consider as far as SHM is concerned. Okay, that is for period is this, for frequency is this, for angular frequency is this, while in terms of spring constant or stiffness, K represents stiffness, M represents mass. Is said to be this here. So now before we take a question here, let's understand equation of simple harmonic motion. Please write equation of simple harmonic motion. Before we solve any exam possible question here, let's understand the equation of simple harmonic motion. Okay, subheading equation of simple harmonic motion. All right, equation of simple harmonic motion. Now, in terms of equation of simple harmonic motion, remember, in terms of simple harmonic motion here, it can either move in a cosine form or in a sine form. That means the movement is said to be like this. Can either move from here, is said to be repeated motion, or it can either move like this. That is here. Please take note. So a simple harmonic motion can either move in a sine form, that is, can either move in a sine form or in a cosine form. Please take note. It can either move in a sine form or in a cosine form. So if it's moving in a sine form, what is going to be the equation of this simple harmonic motion here? Is going to be y is going to be equal to a sine into omega t plus or minus phi. Please take note. Now, if it's moving in terms of cosine here, I'm going to let you guys know when it is moving in terms of sine form and when it is moving in terms of cosine. Please take note. Now, when it is moving in terms of cosine, the displacement is going to be equal to A cos into omega t plus or minus phi. We are going to understand about this formula. We are going to understand the details of this formula. But before then, let's understand when a simple harmonic motion here is moving in a sine form or in a cosine form, okay? Please share to your friends, share to your friends, share to them, okay? Share to them, share in your departmental group. Few persons, that is few persons, is very poor, okay? Now, so that a simple harmonic motion can either move in a sine form or in a cosine form. Please take note, okay? Now, class, if definitely the first angle here, maybe the first angle is starting from the origin, that is equal to 0 here. That means the first angle is not given to us. At that point, it means that the simple harmonic motion is moving in a sine form. That means if we look into here, the angle here, the first angle here is equal to 0. Now, but if the first angle is given to us at a particular point, it means that that particular simple harmonic motion is going to be what? Is going to be cosine formant, okay? Now, class, but that's not the case here. The case is for us to understand the equation, okay? Now, this equation here, that y is equal to a sine omega t plus or minus phi. This y here represents displacement. This a here represents amplitude. This omega here represents angular frequency. This t here represents time. This plus or minus can either be the sign given to us in the equation, okay? While this phi here represents phase shift. That is phase shift. Please take note, okay? This y here represents displacement. A is amplitude. Omega is angular frequency here. T represents time. Phi represents phase shift. Now, class, for here, the same thing here, y is displacement, this maximum displacement, which is amplitude. This is omega, that's angular frequency. This phase shift, okay? Now, the question now is, how do we solve any question that is like this? We compare the standard, these are the standard equation here. This standard before we solve or calculate what we have to calculate. Before of all, compare this and get our parameters before we calculate what we are asked to calculate, okay? Now, let's solve example 1 here. Let's take an example here. Let's take an example here. Please, if the voice is not clear, you can just comment anything you want to, maybe any question also you have, you want us to solve, you can just write it, or any topic at all you want us to solve, and just write it on the comment section, okay? Now, let's take a question here. Example 1, please. Example 1, if y is equal to 0.02, if y is equal to 0.02 sine into 30s minus 400t in meters. Let me repeat myself again. If y is equal to 0.02 sine into 10 minus 400t, or in meters, is, the frequency of the wave is A. Let me write down the option here. 15 over pi of hertz. B. We have this to be pi over 15 hertz. Sorry, A is 15 over 5. The next is 200 over pi hertz. Please take note. C. 30 pi hertz. Okay. D. 400. Okay. Now this is simple harmonic motion here. Okay, the distance is not very poor. Like I'm just trying to check the people here. You can like share on your departmental group. It's very poor. How many persons? 10 persons. Should I end the class? So if you don't want me to end the class, just share on your departmental group, okay? I'm still waiting. I need a lot of persons here. Or if there's any facts or maybe you can't hear me, please try to comment on the comment section there. Okay, let's continue, please. Now, I have this question to be y equal to 0.02 sine into 30s minus 400t or meters. So at this point here, I have to compare. Remember, I told you guys that whenever I want to solve anything related to simple harmonic motion here, you compare the given question to the standard equation, okay? Now, this is the given question here, that is y is equal to 0.02 sine into 30x minus 400t. Please take note. Now compare this guy here with the standard equation in terms of sine. So this will be y will be equal to a sine into omega t, okay, plus minus 5. Now at this point, they change the position, okay? At this point here, they change the position. That means this supposed to be here, while this supposed to be here. But nothing like this the same. Like you have to compare this one here, or you have to this to compare this one here to this. Please take note. The one that has still have to be compared with this, while this one we go with this. Please take note. So if you do that, let's go first under comparison. This is our displacement. This is displacement. This is amplitude. This is amplitude here. That means our A here is said to be equal to 0.02 in meters. Okay. Now they say that everything here is in meters. Okay. Now what does it mean here? It means that anything outside here, since this measurement here is outside, anything outside here is measured in meter. And what are the parameters or numbers outside here is amplitude and what? And displacement. Okay, please take note. So that means this is said to be in meter. Okay, now let's measure. Now, this one, compare this to this. We don't have anything here. Compare this to this, but this one is for S. That means I have to compare this omega t to the one that is having t, and which is going to be this one here. Please take note. So compare this to this is going to be omega t is equal to class 400. Please take note. This minus will cancel this minus here. That is 400 what? T. Okay. Now that means divide both sides by t. That means I'm going to have my omega here. I'm going to have my omega. Let's divide by the common letter there. Dividing by the common letter here, that means omega will be equal to class 400 rad per seconds. Okay. Now the next thing here to compare is this to this. That is our phi is said to be 30s. Okay. Now, but our intention here is to calculate for frequency. How do we calculate for frequency here, class? Now, we ask ourselves, is there any parameters here that is given to us here, maybe amplitude or angular frequency or phase angle that is related to, which of the parameter here that is related to frequency? And the parameter here related to frequency is what class? Angular frequency. We say to be omega is equal to 2 pi f. Please take note. Now, class, let's replace here. Replace the value of omega. When you replace the value of omega here, we are going to have this to be, let's replace the value of omega. We are going to have this to be 400 is equal to 2 pi f. So now let's make f the subject. Since we are looking for f, class, now making f the subject, this will be 400 over what? 2 pi, okay? 400 over 2 pi. So class, I will divide here using 2. This go here is 1. This go here is class 200, okay? But class, our result here is said to be in pi. That means I don't have to replace the value of pi here. So our frequency here, f, our frequency f, we said to be 200 over what? Pi, okay? This is in what? Hence. Now, depending on the option there, you can just click the option, okay? Now, let's solve the next question here on simple harmonic motion to perfect the topic. Let's take a question here. Okay, example 2 here. If y is equal to, but do you guys understand, please? If you don't understand, you can just comment on the comment section. Very important, so that I will reduce, if I'm rushing, I will reduce the way I'm explaining, okay? Now, the class is for you guys, okay? I just want you guys to do well in your physics. And the point here is that anything I'm treating here is equivalent to what you guys is equivalent to what you guys will see in your exam, okay? So please take note. So anything I'm solving here are mostly exam possible questions. So we have treated a particular question on simple harmonic motion. That means you have to take note of simple harmonic motion. So now let's solve the next question so I can perfect everything about simple harmonic motion, okay? Now let's solve example 2 here. Example 2. If y is equal to, let's solve example 2 here. If y is equal to 0.02 sine is an equivalent question 30s minus 400t in meters, the wavelength of the wave is, they said if y is equal to 0.02 sine 30s minus 400t meters, the wavelength of the wave is A, A, 15 over pi in meters. B, pi over 15 meters. C, 60 pi meters. D, 10 over pi meters. Sorry, this is 30. Okay, class. Now let's try to solve this question here. This question here, from this expression here, we can know that this question is from simple equation of simple harmonic motion. Please take note. From this expression here, it means that this question is from where? Simple harmonic motion equation, okay? All you just have to do here is understand how we solve any equation on equation of simple harmonic motion, okay? So remember, I told you guys that whenever you have a question here, you compare this given equation to the standard equation that looks like this, okay? And you don't have to solve what you're asked to calculate. You first of all find the parameters from this equation first before you calculate what you're asked to calculate, okay? But before then, let's try to check the option here. The A here is said to be 15 over pi. That means now replace pi as 3.142. That means pi remain pi. Please take note. Pi over 15 meters, 60 pi meters, D 30 over pi meters, okay? Now, class, let's try to solve this, please. Now, in solving this, class, we should understand that I have to compare this given equation here to this equation. So this is the given equation here. Y is equal to 0.02 sine into 30s minus 400t, all in meters. So let me compare this guy here, remember, to the standard equation that looks like this. So that would be y is equal to a sine into omega t minus what? Phi. Okay, please take note. Sorry. Okay, let's go. In comparing this, this is displacement, this is displacement, this is amplitude, this is amplitude, okay? Now, class, at this point, they interchange this part. Remember that the one that has t should go here. Please take note. While the one that is not of t should go here, okay? But there's nothing wrong here. It's still the same. So that means this one will be compared with this. So since this is minus, this minus will cancel this minus. While this one will be compared with this. Please take note. When you do that, it means that the amplitude here is said to be 0.02 meters. So amplitude is equal to 0.02 meters. Please take note. Okay, now let's compare. This one go with this one here. That means omega t is equal to, please take note of this, 400t. Now divide both sides by t. I'm going to have our omega to be equal to 400 rad per second. The unit of omega is said to be rad per second. So now let's compare the last one here. That means this one will go with this one here. So our phi here will be equal to class 30. Okay. The parameters here from this given. Now the next thing I'm going to do after comparison here, I have to calculate what I'm asked to calculate. I'm asked to calculate the wavelength. Please take note. And wavelength is being denoted by what? Lambda, like this. I'm asked to find the wavelength, and wavelength is being denoted by what? Lambda, okay? Now, let's try to know the parameters or the parameter that is being related with wavelength. Class, this amplitude here is not related with wavelength. Please take note. Now, this angular frequency is related with frequency. While there's a formula in terms of phase angle that we say that phase angle is equal to 2 pi s over what? Lambda. Please take note. We also have what we call wave number. That is, wave number is k is equal to 2 pi over lambda. Please take note. This is called phase angle or phase shift. This is called wave number. Class, If you're asked to find the wave number of any wave, the formula is said to be k equal to 2 pi over lambda. If you're asked to find, maybe you're asked to find the wavelength, and then the phase angle is given to us here, we can just use this. Phase angle is equal to 2 pi s over what, lambda. So from this parameter here, either amplitude or angular frequency, the only one that is related to wavelength is said to be phase angle. Please take note. The only one related to wavelength is said to be what class? Phase angle. So class, let's try to solve this. In solving this class, I will replace the value of my phase angle, which is this one here. I'm not asked to find the wave number. Please take note. So the answer, this phase angle here is said to be, this phase angle here is said to be 2 pi s over what? Lambda. Let's replace. What's my phase angle here? Remember, it's this what? 30s is equal to 2 pi s over what? Lambda. But my intention here is to make lambda the subject. Making lambda the subject here, our lambda